All right, let's get to it. Good morning, everyone. My name is Andy, and today, thank you, by the way, for coming in today, and please stay for the last presenter. Probably the future of ICT is going to be transformed this afternoon. You like that, yeah? Just kidding. But let's get to it. I would like to introduce my proposed embedded system, which is called a smart warehouse, an Arduino-based embedded system. Just recently, I got interested in knowing something like what makes really take into the thing that we do. Just give me 1 second. It's like, all right, there we go. Make me interested, like what will happen to the whole inventory? I mean, the warehouse operations. So that's the main topic that I'll be doing this afternoon. So I got 5 agenda. First, I want to share with you like how or what makes this. Or how I can conceptualize the idea. I would also share like the main features of the project, and also tackle on the stakeholders and even what exactly the system can provide to the real business as a warehouse. And the other is I want to talk on quickly on the hardware design, as well as the system software architecture. The hardware I'll be just sharing with you like the lists of sensors and modules that I used for this project. The system software architecture, I'll just going to show you a very glimpse of how the program or how the system really works. And I also want to share a few more testing plans, or just like 1 or 2 probably, or probably 1 if time consumes. And lastly is the project timeline, how I conceptualize, what made me decide to come up with this idea. So all of these will be discussed in a bit. So let's get into it. The background. So as I was saying, I got interested in knowing or like understanding how to create an embedded system that would promote a safer, a quicker, and a smarter warehouse environment. So that being said, that's exactly the reason why I created this one. I got 2 main features of this project, which is the bread and butter, the backbone of my project, the icing of the top of my cake. So these are the safety environment and the effective retrieval management. When we say safe environment, I'm looking at the forklift equipment, or even those service trolleys are embedded with sensors to help prevent any collisions or even hazards inside the workplace. And by doing that, I want to see like the system will automatically control or regulate the speed of the equipment, and even provide some sensors or like an RGB LED, as well as will create a buzz sound. And the second one is the effective retrieval management. I'm seeing like all the shelves, all the racks are fully automated with RFID system. With the use of RFID tags, we'll be able to track or find the inventory as quickly and as effective as possible. So that's exactly the main features. The stakeholders would be the warehouse staff. They basically use and operate the forklift equipment, the sales team, the salesperson who goes inside and outside the store warehouse. We also include the store management who oversees the whole operations of the store, and the customers. Overall, I'm looking at the performance of the whole embedded system to create and improve productivity, a safer operations, reduce operational costs, faster turnaround, and on top of that, to satisfy the customer. And this is this hardware design. Most of these sensors and modules you are all familiar by now, I'm sure. But I want to introduce one thing, which is the Hall effect sensors. What it does, these sensors are commonly used to measure proximity sensing, as well as the speed of your wheels. Most of the cars lately, or nowadays, especially the autonomous cars, they're actually using a Hall effect to regulate the speed, and that's exactly what I'm going to do with this project. If you want to know more about the Hall effects, you have a wide range of variety online. You can just type in and you'll be able to see that as well. And this is the use case scenario. I'll be discussing this further in the next slide. So going back to the main features, the safety environment and the retrieval management. I'll start with the safety environment. So basically, with this project, I identified a safe distance and hazardous distance. So the proximity sensors will detect if it reaches to the maximum allowable distance, which is anything above 500, anything below 500 millimeters will trigger the Hall effect sensors to regulate the speed of your wheels and all that stuff. And that would also provide you the alert systems by turning the green lights into the red one and also creating a buzz sound to alarm the drivers of the forklift and even the people around that there's something, like there's a close contact with anything. Retrieval management, the RFID system, with the use of RFID, we'll be able to track, locate, and even get or pick up the items as quickly as possible. The LoRa, this is a way of using a communication means between the sales operation team and the warehouse by sending a real-time update and whatever inquiries that they do have. The testing plan. For the benefit of time, I'm not gonna discuss everything, but I just want to share one important, like the forklift equipment. I identify, like I said, a safe distance and hazardous. So what it does, if it reaches to any form of interference, it could be a block or a thing or a person who close near the forklift. If it reaches below the 500 mm maximum distance, it will trigger the Hall effect to reduce the speed, as well as to provide the lights to the RGB LED, and as well as to create a buzz sound. So that's exactly what I want to do with the system. The timeline. So before anything else, I think most of you guys know, like I work at Harvey Norman, so as a salesperson myself who goes inside the warehouse, I know exactly how the warehouse can get busy at all times, and I know exactly how risky it is for me to get up or pick up an item and get outside from the warehouse safely or with a complete set of feet and complete set of hands. So those are things that I consider, like, what if, I undertook a very quick feasibility study and search if there's an existing system already available in the market. So I'm thinking of, what if we can actually create a system like this that would eventually provide safety and effective retrieval management for a warehouse operations, and I'm sure it's going to provide you a much difference in any form. So currently, I'm still working on the codes. That's the real challenge right here, because I'm going to implement everything in one, or like I'm making everything to make work all the time. So I'm still working on it, but hopefully, I'll be able to make it run before the deadline, which is next week? But I'm not sure. So that's basically it, my presentation. Thank you again for listening. Any questions? You'll free to ask.
Just a comment, like the Hall effects that I gave you, the sensor, are you able to measure that 500 millimeters, or have you checked it, or?
I tried testing it, just like showing the amount. Yeah.
Okay. But I mean, you could adjust that value later, that's fine. Because, like, for Hall effect sensors, the range has to be very small.
Yeah, that's right.
Within 2-3 centimeters, it works well. Yeah. Anything further than that, you literally have to use a very super magnet kind of thing to actually have any change.
And that's exactly the reason I asked if I can change the measurement, because I was using CM then. Because I cannot really detect the distance as clearly as possible because of you just mentioned that.
Yeah, CMC is not possible.